What's up, everybody? It's Dustin from DC Media, and today we're going to talk about Optane. Should you be excited for it, or do you even need it? Alright, so if you guys have been watching the Kaby Lake release from Intel, you've probably heard the term Optane thrown around a little bit here and there, talking about the new motherboards and such are being, sent with Optane, I guess, certifications, or saying that it'll work with it. We don't really know how they're going to be utilized or how it's going to be implemented just yet, but it will work with the new chipsets. So with that being said, what is it? Well, it is a 3D crosspoint technology. It's a non-volatile memory that it's the biggest breakthrough in about 25 years. Now, people don't say that lightly. It really is. It's blurring the lines between system memory and storage memory, where storage memory is your typical non-volatile, very dense, very slow, even SSDs are considered slow, storage and memory, where the power's off, it can still store memory. And your DDR memory, your DIMM slots, that's low density, extremely fast, but it's volatile. It doesn't store when the power's off. So this 3D point cross platform, it was developed in conjunction with Intel and Micron. Intel calls it Optane, and I think Micron called it Quaint X is what it was called. Don't know why. I don't know where that name came up with. Either one, actually. But the exciting thing is where this technology is taking us. See, the inevitable solution here is it's going to revolutionize and change how a computer is actually designed and built. Since it's blurring the line between RAM and storage, the two various types of memories, we're now going to start seeing some implementations moving forward that it's going to be rather interesting. So why is it so interesting? Basically, they are creating a memory system that's 1,000 times faster than NAND flash, or I should say up to 1,000 times faster than NAND flash, and up to 1,000 times longer on the lifespan. And the way they did that is they took out the capacitors that you have to charge in order to read a hard drive. So in a standardized hard drive, they charge a capacitor, and when you go to read it, if it's charged, it's a 1. If it's not charged, it's a 0, to get your binary code. Well, they're taking out that entire process so you don't have it anymore, which is lowering developmental costs and production costs and increasing efficiency. So we're getting faster speeds, we're getting lower costs, and higher efficiency. Pretty much everything that you want from a brand new product. Now, it's going to come with its pros and cons, I'm sure, and we don't really have a lot of information how they plan on implementing it just yet. But we do know there's a couple ways it's going to be utilized. One way is like a system cache. So it's going to help your old, slower hard drives to be able to use their system, probably in an M.2 form, like they've already released at CES, in 16 gig and 32 gig variants, as a cache system. So that way you can help, pull and read and write memory. While you might not be getting the full utilization of it, it's still going to help your slower hard drives become a little bit faster. Now, once storage capacities become much larger in that product line, you're probably going to see that they're just going to do away entirely with other storage devices. So you're going to wind up seeing terabyte and 2 terabyte and whatever else there might be, and it's going to have the read and write speeds and longevity that you're going to want over even NAND flash, with up to 1,000 times faster and 1,000 times longer lifespan. Now, in some cases, supposedly, from what we understand, from what Intel has told us anyway, is that this new architecture is going to be able to understand what your system that you're utilizing requires. So if you don't need lightning fast, response times like you get from your DIMM slots, it's going to shift over and it'll pull it all off of your Optane drive. So, and we're talking about nanoseconds of difference here, and here's a graph to show you. The differences between these two technologies is pretty minuscule, where the difference between everything underneath it, your standard NAND flash and hard drives, you can see the difference there. Latency is massive. So for us, in most cases, we probably wouldn't even know if we're using RAM or if we're using our Optane drive. And inevitably, my thought moving forward is that once we get a bus system that's able of converting this and carrying the bandwidth, we could likely see this completely do away with DIMM slots. Now, that is way in the future and a long time away, but it's an interesting concept to say the least. But even with PCIe 4 coming up, I think that's limited to like 32 gigs a second. That's still way too slow. We're going to saturate that immediately with this type of product. But again, it depends on implementation and how it's going to be read. And we don't know, or at least I don't know just yet, how they plan on implementing that in its entirety. And we don't know what the end products are going to be. But we do know that it will decrease power consumption, it's going to decrease cost, and increase performance. So we're going to get faster boot times, faster application loading times, faster system recovery times. All these things are going to be greatly expedited. So not only for us, for gaming and things like that, but more so for like the deep learning systems and data mining thing, whatever it might be. Anything that's going to utilize memory in a way that's being hampered right now by even NAND flash. So it's interesting to see where this technology is going to move going forward. But with that being said, guys, I really don't have a lot more to say about it. We don't know the cost per se on what this stuff's going to cost moving forward. We know it'd probably be 4 to 5 times the cost of whatever a NAND flash device is. At least that's what I'm hearing being kicked around. But that's just hearsay. That's nothing confirmed just yet. But with that being said, guys, I do thank you for watching this video. If you like it, give me a thumbs up. If you didn't like it, give me a thumbs down. And if you have any questions, leave in the comment section below. And I'll see you guys in the next video.